Alright, hello everyone, welcome back to Dynamic Modeling of Buildings and Cities. My name is Josh and today I'll be showing you how to import the .osm data into 3D Rhino. So in the previous video we talked about how to input the data in OSM and how to export it, and right now we're going to put it in the Rhino modeling. So this is quite different from MapRoom. In 3ds Max, MapRoom is a very direct plugin, but the difference is that at MapRoom you need to pay for it. It's a really powerful tool, but if you have the money, by all means use it, and I do recommend MapRoom. But today this is an alternative that I want to show you if you do not have MapRoom and you prefer, for example, to work in Rhino because you're more comfortable in working in polysurfaces or some other reasons. So go to Food for Rhino first thing, and then log in with an account. It's totally free. You don't have to subscribe or anything. And then you want to find elk. So this is the plugin that you want to download. So elk is not Rhino plugin, it's rather a Grasshopper plugin. And you need to have a Grasshopper. So if you have a Rhino, for example, Rhino version 6, it already has Grasshopper included in the Rhino, but you have Rhino 4 or 5, you need to download Grasshopper for that version of Rhino, because Grasshopper is embedded into Rhino installation starting from Rhino 6. And if you're in Rhino 7, well, it's still work in progress, you'll still fine. So download the latest version. I've already downloaded mine, so this is the latest version over here, 2.2.2.2, and you can just click download. And it immediately will download the zip. And if you open the zip file, it has a folder right here. It varies from plugin to plugin, so it depends on the developer. You want to have this file here. This green.dha file is called Grasshopper Assembly file. So this is a plugin that you want to install into Grasshopper. So the way to install it is really simple. It's similar for every different component. So go to Grasshopper and go to Rhino, click File, and then Special Folders, Component Folders. So as you can see here, these are all the Grasshopper Assembly file, the green file that I've already put here. So that means that the plugins has been installed. And as you can see, I've put also elk over here. So I've put all the DLL because they might have settings that can only work when the .dll files is in there. So you want to also copy everything. So that's why I said copy the whole folder. So there's another component that might be, there's another plugin also that might need to go installed into Grasshopper, but it has a different colors. For example, yellow or blue, or for example yellow, and it's just the one that you want to have a look. So it's called user object here. So it's called Grasshopper user file. It's yellow, so it needs to go to user objects. So remember, the .gha, the green file, needs to go to libraries, and the user object needs to go to this one here. So this is going to work in Ladybug and other plugins that has a yellow file like this one. So the way to access this from this Grasshopper is from special folder files, special folder, and go to user object folder. So since I've already installed it, that means that I can go straight into elk. But if you haven't installed it, after you copy the file into the libraries folder, you need to restart Rhino just to jumpstart the plugin. So what you want to do is to have elk over here. There you go. It's called location. So it requires a file. So what kind of file is this? This is the OSM file that we have downloaded from before. So we want to have file path, click on here, and then we'll select one existing file which we put in download. So there you go. And as you can see, the whole thing is kind of working, and it has four different information that's going to be extrapolated. For the first one is longitude and latitude. These are the coordinates that we should have put in the Osm data when we are exporting it, but we did it manually. And this is the file showing the path to the OSM file at the moment, where we actually input it from here. And this is the OSM data that you need. So all here is in point, but it can be generated into lines and 3D blocks. So the second component you need is this one here. It's called OSM data. So it needs an input from this one to here, and that one to there. So right now it's currently loading. It's currently thinking in generating all the stuff that it needs, and there you go. Right now it's generating trees, and to change the trees to other type of layer, for example, if you want to building, click right click on this component, and then change the feature type to, for example, other things. Like currently I want to have it buildings, and you want to create 3D buildings over here. So click that. It's currently thinking. Yeah, there you go. So as you can see, whether if you want to know whether it's finished or not, you can see in the bottom corner here, whether the solution is completed. So after I've set this as 3D buildings, it creates another set over here. So what you want to do is just to have a beep up, and just click it there. And there you go, just zoom out. There you have it. This is Melbourne CBD, and currently we know that there's a lot of buildings that hasn't been inputted yet. So let's try to find our building. Which should be around here somewhere. So that's Flagstaff. There you go. That's our building that we added in OSM. So currently it's already exported to Rhino, and this one here, this component here, will only show the footprint of the building. So you can also hide this, and it shows only the 3D. And if you want to, for example, you want to show also like roads, waterways, and trees, this is working on organizing the layout and organizing the components, because you can treat this component as a single layer. For example, this here is a layer, is called a 3D building layer. You can group this and call building just for the purpose of the exercise. And then I can create another one below here with a different layer, and we want to show, for example, the route. Yeah, for example, route, and then third one here is waterways. And then fifth one here, highway. And last one here is the trees. Now trees are a sub layer, so you need to go to natural, and then you can select feature subtypes over here, and you can put other type of natural elements, natural features, like for example trees here, add, and you can also select multiple sub elements, and it is shown in here. But for the purpose of this exercise, I just need to show you how to do it tree, because we don't really need other type of elements in here for the moment. So okay, now I'm going to show you. So let's just organize this a bit. Now these are all lines, polylines. Curve, let's just do curve. Polyline should be polyline. There you go. Now these are all the curves of a route. So we're showing route. Then this one here we are showing the waterways, and this one here we are showing the highway, and this one here we're showing trees. Now trees are quite different from the rest. Sufficient point for polylines. Yeah, we can ignore that. So trees are quite different from the rest because trees are in points. So you can actually download your own 3D polymesh trees and then use the reference point from here, and then you can orient all the trees into this point. Now this point, oops, point. There you go. These are all the locations of the trees. Now I'm going to show you how to orient this tree to here, but I'm just going to show you that you can do it. So for example, make a cylinder. Going to exaggerate it a bit. Then make this as a wrap. Set one wrap, and then we want to have the base center. Now this is a component, so if you click Control Alt and then click this one, left click, you can see the source of this component over here. So I took it from Heteroptera. That's a plugin. There's another Grasshopper plugin. So what it here, oops. So what here is that it's going to generate a center of the input geometry, but I can select the basement center, which is this one here. So it's a really handy tool, and I do recommend it. So what you want to do is just to orient this thing here into every point there. So orient the geometry, the starting point, and then the end point. There you go. And then you can actually play around with the rotation and the scale. And for example, scale center, you can select like that. Now this is going to be quite some. It's a little bit heavy. Now you can change the factor. For example, you want to have randomized scaling, so you can use pseudorandom. It's called pseudorandom. Random. So it needs range, number of random values, and seed. So what you can do is just to list number. List length. So list length is that to capture how many elements in a list. So for example there. Now the reason why I do this is that to make sure that it generates the same number of trees that are in here. So you can select the range. So the range will be between 0.5 to 1. It's going to be the range. So you need a domain. You can construct a domain. And then you can control like so. What it does is that to generate this thing here is going to generate this amount of number, which is this thing here, this component will generate this amount of number, 1550 numbers, different numbers, that is ranging from 0.25 to 1. So if you can see, there's going to be 15,050 numbers, 15,050 random numbers that is in between this and that. So what you want to do is just simplify, just to make sure that it's the same tree. So that's the same tree, like so. So the tree is that if you see that there's a number in the bracket below the 1550, like 0, 1, 2, 3, that's called a tree branch. So just to make sure that it's the same number, or is in the same level. With this one here, it's going to match up. So there you go. That's the number. Those are the numbers. Oops, need to craft it again. Need to flatten this. And need to craft this. There you go. So the issue here is that you need to put the numbers in 1550. So what I did wrong just now is that this will only produce 1. This will only produce 1 because it's going to capture like the 1 tree, for example, the 0.0. It only has 1 number, so it's going to generate that number. So you want to make sure that it's flattened, so it generates the total amount, 1550. So as you can see, there's a lot of numbers here. So this number are generated randomly between 0.25 to 1. Then what you want to do is just to do this. Then just simplify. It's going to scale according to that number. So what you want to do also is just to hide this, then flatten tree, hide, and then it's going to rescale. It's currently thinking. It's going to take quite a while because this is quite a heavy. Wait, never mind. This is quick. So as you can see, there's a lot of varied scale because we scale it in the randomized manner. So this is really useful. And if you want to, for example, if you want to rotate, use the same method of this one. This is going to be really useful and it's powerful, and you have more control of editing and putting the trees inside in the model. Then, for example, if you want to rotate it, you just use the same principle of this one, but the difference is you just use rotate. So the geometry is this. Maybe shouldn't that. So it's just a matter of the angle right now. So from 0 to 360, like to 270, for example. Now, since it's a cylinder, the angle will not be very visible. And then that's the angle. Just change it to degrees. So the plane and then the geometry, the base geometry. So the plane, you want to have this one, the center of the bottom of the tree, and then you want to rotate the geometry. And there you go. It's not going to be visible again So for example, if I want to change this to pyramid, and change this to pyramid. Now everything's going to be changed to pyramid, even the scaling and also the rotation. You can see there's a lot of there are different rotation over there. But you want to rotate the trees after you scale it. So what you want to do is just to change the geometry to there. There you have it. Hide everything, and you have to rescale and rotate the trees. So this is a really powerful tool. You can actually edit everything in here, and especially if you want to put trees, so to have a more detailed model. But if not, by all means, you can hide everything here. You can hide or even delete everything here. Preview off. I'm just going to internalize this. Yep. So if you want to do the trees like I showed you just now, I would recommend you to find a very low poly mesh 3D trees, because if not, it's going to be very, very heavy and it's going to load up your model really, really high. So I'm going to hide that. I'm not going to show that for now. But this one, going back here. Now the way I separate this is just by layers again. The reason is just to, when you want to bake this into Rhino, you can have different layers. You can have directly in different layers. For example, now you can create a new layer, buildings, waterways, highways, routes, and another one, trees. And you can just set the color. For example, orange, waterways, blue, highways, gray, routes, red, trees, green, dark green. So when you bake this one, for example, this is the highway. You can directly bake this as a group to highways. And there you go. Bake this. Oh, what is this? What's this? Yeah, that's a waterway. Bake this directly to waterways, and so on. And then the one here. Bake buildings. Make sure to group it. And then when you hide it off, you want to make this the trees that we edited earlier. Group. There you go. So as you can see, this is a really powerful tool to organize everything in Rhino as well. So when you want to edit, for example, just the buildings, you can just ungroup this, and you can hide the rest. You can hide the rest of it, and then you can edit the buildings directly. Change that to shade, and you have it in poly surface, so you can explode, you can join it back, and then you can edit it like so. So it's a very different thing from MapRoom, because when you download it from MapRoom, it's already downloaded in a package. You can't change it as much as freely as you can compared to this one here. So it depends on how you use the 3D model and how you work, which one you prefer also, and other factors like, for example, you don't want to pay 300 euros for MapRoom, and you prefer this one here, and you have all the data. By all means, you can use any software. But I'm just showing you how to use it in Rhino compared to MapRoom. It's a different kind of approach. But in Rhino, you can have additional details, like for example the trees and or lamp posts or something like that. So I'm going back to my trees. right now. Going to bake, and going to show you what it looks like if the tree is much smaller. Yep, so I've already scaled it enough, I think. So you can try it on your own if you want, and then just set one rep. There you go. Yep, there you go. There you go. That's the mini trees. Looks quite small. But yes, that's how you put the trees and other details in the 3ds in Rhino, and how you input OSM data in Rhino. So that's all for today's video. Thank you very much, and I'll see you next time.